right, so some of the stuff that we're going to be doing in this next lesson is just like the last few. It should be familiar. It should not be a new concept for you, so hopefully we can breeze through it pretty quickly. So remember that an exponent is a way to indicate repeated multiplication by the same number. For example, if n is a positive integer, then x to the n power would be x times itself however many times. So write out each of the following means as an extended product and find its value. So for letter A, it would be 2 times itself 4 times. Well, 2 times 2 is 4, 2 times 2 is 4, so that 4 times 4 equals 16. The next one, 3 squared, which means 3 times itself twice, which makes 9. And the last one is 5 times itself 3 times. So 5 times 5 is 25. 25 times itself 5 times is the same thing as how many cents would it be if you had 5 quarters? Well, that would be 125 cents. So of course, just as with numbers, variables can also be raised to exponents other than 1. So looking at exercise number 2, write out each of the following involving exponents means as an extended product. So x to the third power is x times itself 3 times. Then x squared is 2 x's, and y to the fourth is 4 y's. And then we have 2 squared. So 2x squared means that you're going to have the entire expression twice. What we're going to do is we're going to actually write 2 times itself twice and x times itself twice. So keep in mind that that 2 times itself twice is the same thing as 4 x times x. Letter D, this is the part that gets really confusing, is trying to figure out what exactly is being raised to an exponent. You'll notice that on letter D, x is raised to the 4th power and y is raised to the 3rd power. So the 4 is just 4. It's not raised to a power. So it's going to be 4 times x to the 4th power times y to the 3rd power. But then we look at letter E and 9x squared. So there's some interesting stuff going on here. We have 9 to the 3rd power and we have x squared to the 3rd power. So 9 to the 3rd power is just 9 times 9 times 9. But then I have x to the 2nd power, so x times x, and we have to do that 3 times. So we have x to the 2nd power times x to the 2nd power times x to the 2nd power. So you really end up with 6 x's. And then finally, letter F is -4 times -4. And then we have x to the 3rd power, and we have to do that twice. So we have x to the 3rd power twice. One of the nice aspects of exponents is that they follow very predictable patterns, often known as exponent rules, and they do rule. Let's figure out the simplest one in the next exercise. So write out each of the following products and then express them in the form x to the n power. Well, keep in mind that this is x to the 2nd power, and now I have x to the 3rd power. If I combine them, I get x to the 5th power. Same thing with the next one, letter B. I have x to the 5th power, and then I have x to the 2nd power, which makes x to the 7th power. And finally, x to the 4th power, and x to the 4th power becomes x to the 8th power. So that rule, the pattern, is that x to the a times x to the b becomes x to the a plus b. You combine the two exponents but keep the base. You need to internalize this rule, so you have to think about it until you're absolutely sure you understand why it works. Eventually, we will extend exponent rules to weird situations with all sorts of exponents. So quickly write each of the following products as variable raised to the single power. Well, is the base the same for letter A? They're both x, so it stays x, and then you add the exponents. 4 and 9 makes 13. Letter B, is the base the same? Yes, the base is x. So now we combine 2, 3, and 4 to get 9. And same with letter C, the base is 9. You combine 2 and 6 to make 8. So it's just saying if you were to rewrite each of them, how many would you have total? Often you will need to be able to multiply more complicated terms and write them in as convenient or simplest form as possible. So the steps to simplifying the product 5x to the third power times 2x to the seventh to simplest terms are shown below. Write in what justifies each step. So in step 1, they took the 5x to the third power times 2x to the seventh power, and they put everything that's the same next to each other. So the 5 was times the 2, and then the x to the third times x to the seventh. So this one is the commutative property. So all it did is it changed the order it was listed in. The next one, it took 5 times 2 and put it in its own parentheses as well as with the x's. So this one is the associative. And the last one, it took 5 times 2, which is simplified to 10, and then x to the third and x to the seventh to make x to the 10th. And this one is exponent rule number 1. This is the rule we learned up above. Exponent rule number 1. So for this next one, we need to become fluent in the manipulations. So please pause and see if you can do these on your own and then check your work. So 2x to the seventh times 8x to the fifth. So we're going to use the commutative and the associative property at the same time to take the coefficients of 2 and 8 and separate them, and then the x to the seventh times x to the fifth and separate them. Well, 2 times 8 is 16, and then x to the seventh and x to the fifth becomes x to the 12th power. Letter B, we're going to do the same thing. We're going to take that -4 and multiply it by the 2 separately, and then I have x to the third times x to the second that is separate. -4 times 2 is -8, and x to the third times x to the second is x to the fifth. Now this last one, you will see that all it's doing is it's squaring it. So we're going to have -6x to the third times itself twice. So we can take that -6 times -6 in 1 and x to the third times x to the third in 1. So -6 times -6 is positive 36, and x to the third times x to the third is x to the 6th power. That is everything for lesson 7. Hopefully with the practice this will become very fluent for you.